Vibration sensor. Vibration sensor is one of the most common sensor which is used to identify if a machine is working well or there could be any potential issues. There are so many vibration sensors out in the market. They can be categorized in two types of sensors. One which will send you raw data, which is can be parsed and does the FFT and get the final results. Then there are two second type of sensor, which is process type of sensors, which are getting more common given for the wireless range and all. On process mode, you will be getting process data like acceleration, velocity, displacement, and frequency. Over here we have NCD vibration sensor V3. This sensor has three modes. One, it can send process data. Number two, it can send you raw time domain data, which you can pass through FFT and get all the data you need. And third is process data with raw on demand. This is one of my favorite mode of operation. How does this work is pretty simple. You get a process data which looks something like this. As soon as you get the data, you say like, hey, the velocity is going crazy here. Then you request the raw data from the sensor. The sensor sends you raw data, then you pass through your FFT and you can get all the frequencies where you might see a noise or problem. Most of the cases you don't need to look at the data because in all honesty it's pointless when machine is going good, and you don't need to parse every single time, you don't need to push data to cloud, you don't want to unnecessary computing and all that, so you only do that when it's needed. So an NCD sensor does all these three modes. You can choose either one of them. Uh, in this video, we'll talk about how you can use Node-RED to display data and configure few of the sensor settings. Node-RED is really easy to use. Initially, you might find a little bit tricky, but as you go along, you'll find it's really good and it works really well. So to do that, I'll go into the terminal and I'll open Node-RED. Once you do that, you'll say it's running at this, so I'll go over here and open this here. There are some flows which you can find on our website or on GitHub which you might find useful to get started. If you go here, just check NCD IoT wireless vibration library. The sensor type which we'll talk about today is AD, so I'm just going to download all three. Of these flows. Okay, now go to the Node-RED. The first thing you want to make sure that you have the updated NCD row node library. To do that, click here, then click on Manage Palette, and then look for NCD Red Wireless. So it looks like I already have the latest one, so I don't need to update. If I didn't have, then I should have updated. Once you do that, go and unzip this. So you got all these three flows. I'll import one of the flow. Importing is super easy. Click on that, click import, select from computer, then go download, then go here and type 80. Click at that, current flow, import. Now you got here. By default, this is disabled. So I'll go and enable the flow from here, fairly straightforward. This computer does not have a wireless receiver. So in this video or in this setup, I'm using a USB modem, which you can find if you click on NCD product page, buy now. So I have this USB modem connected to my computer. Now my first job will be finding out where this USB modem is connected. Make sure the port is correct. The flow which I imported was from other computer. That computer was using port 5, so I need to change according to mine. Looks like, so to do that, just click on add new, click on this pencil symbol, USB to serial, then look for the port, and the port is this one. Then click RSSI and then click add and then click done. You will do same for this here, here, and done. There is always one more place where you have to set up the USB modem. I generally forget it and it bites me in the end. So you want to make sure you come and change this one also. Once you make these changes, there are a couple more changes which we'll talk about in a minute, but these are basic changes. Once you do that, click deploy. And you can enable this debug node also, click deploy. After doing that, you'll go ahead and delete. There are some other sensors on in the area as well, so I might be getting other packets. So let me turn on my sensor now. I just turned on my sensor. I should see a run packet which will say RUN. Yes, from this one I got the run packet, and then my sensor address ends with 8C, and then I got a 8C acknowledgement packet, and then I should be getting a data packet fairly quick. Once I do that, now I know my packet is 8C, so I'm gonna go ahead, here's the packet, data packet, and change this address. It's very important. Make sure you go and change this to 8C. If you scan, it will list down all the modules or all the sensors it's listening to, 8C. Once you select this one, you normally select to one channel vibration. If not, make sure you select it. Let's talk about two other settings here. Node ID and delay. Node ID is a parameter which you can use to identify device from 0 to 255. In rest of the NCD sensors, this parameter is not very important. But in this one, it could be very important. The thing is, there are so many sensors in the area, and these sensors send a lot of data. If you have only one receiver, you can run into RF issues. So what we did is to avoid that, if you set your node ID from 0 to, let's say, 10, then what will happen, the sensor node ID with 0 will send data first, then 1 with 1, then 2, 3. They will space out evenly to make sure everybody is getting some room on the RF and sending the data. So this is why it's very important. The power is by default 250 milliwatt. I'll set it this one. The mode, as I was talking about, there are three modes of operation: process, raw, and process raw on demand. I'll select the raw on demand. Filtering, I will keep the filtering enabled by default. When the filtering is enabled, the bandwidth maximum is 32 kilohertz. If you want to disable it, you can go up to 8 kilohertz in the bandwidth. The measurement mode, I'm just gonna use the milli-G and meter per second square and all that. Set on request timeout. So earlier we were talking about a feature where the sensor will stay awake after sending the data to wait if the user wants to request the raw data or no. So you can change the time, how long the sensor stays awake after sending the packet and waits for your command. Output data rate, again, very important feature. All the machines out there have different ODRs. Different RPMs at the frequency they're running at. Based on that, you want to set the ODR settings. The ODR table can be found in the product manual. If you scroll all the way down, you will see that. Raw data. Let's say you want to request the time domain data and you want to do analysis on your own computer or in your cloud or wherever you want to. You can set and ask sensor how long you want to sample for. There's sampling duration. Sampling interval. After sending the data, sensor goes back to sleep, and if you set to 5 minutes, then it will wake up after 5 minutes, will turn on the sensor, will take the sample and send the data. Set RTC. This sensor got a real-time clock. Full scale range. You can change this, and based on what is your requirement, if you stay in 2G, you get the best resolution. If you get 16G, resolution will decrease. and then access. By default, all three access are enabled. Once you have all these settings, click done and deploy. I'm just gonna go ahead and turn this off so only we see only debug from this one particular node. The sensor I have is for demo purpose and is sending data after every 1 minute. By default, when we ship the product, it will send data after every 15 minutes. Is this to save batteries, and vibration is a parameter which does not change drastically. It will take some time, sometimes could take weeks before you will see something. So here's some data we can talk about. Right now, the by default mode is mode 0, ODR is 800, temperature is this, and the sensor is not connected to anything, so I'm getting all the zeros. Now let me configure the sensor. To configure the sensor, you will click on this button and will say configuring. After that, go to your sensor and you will see two buttons. One will say R, one will say C. So you will press and release the R and then hold the C button for 6 seconds. And once you release that, you will see it will send a message and you will see this notification over here. In some cases, I've seen that this Node-RED configuration will fail in first try. So you don't have to do anything else, just go and press the reset button and then press the configuration button again and it will configure, and you can check if it went through or not based on these parameters. So as you can see, true, 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 all the parameters we set are true. Now I'm gonna clean up, I'm gonna put this one back into run mode and I'm gonna press the R button. Now we'll see if it changed the parameter. The parameter we changed were mode of operation and ODR. So as you can see, we went to mode operation 2, ODR is 400 and temperature is this. Now your next question might be how to request the data. So to request the data, you will need to copy this address from here. We'll go to this inject node, and in this node you will enter the address where you want to request the data. Click done, click deploy, and then click on this inject node. Once you do that, next time data will come, the device will request the raw data. You might see the LED on the device will be blinking quite a bit because it's sending a lot of packets. As you can see over here, the data came at 1513, as you can see here, and then 16G, ODR was 400, that's what we set, access was all three enabled, and this is where you will see all the data packets. This data packet can be sent to your own FFT. You can run the FFT here, or if you want to do any further analysis or any further processing, you can do that. That is mostly about it. There are so many applications, there's so many problems you can solve this using this vibration sensor. This can also draw a chart and graph, which is pretty simple already. You will click on dashboard. Let me see where that might be. I guess here. Yep. Then you click on this tiny button here, and you're able to see the sensor graph, the ODR, temperature, and all the parameters here. And as they change, you can see it. In future videos we'll talk about how you can harvest the data and make a good use of it, why you need all these data, why can't you just have one parameter and be good with it. So see you later.